The Parker Solar Probe is one of the most incredible pieces of human engineering ever created, and there are several reasons for that. First, it's the closest spacecraft ever sent to the Sun. Second, it studies the solar wind and magnetic fields. Third, it helps us better predict dangerous solar storms that could wipe out our satellites and disrupt our telecommunications and our power grid system. Fourth, it reached speeds of over 430,000 miles per hour. And fifth, it will survive temperatures as high as 15 degrees Celsius when it gets within 6.2 million miles of the Sun. In this video, we'll go over all of these reasons in detail and more. The Parker Solar Probe launched from Cape Canaveral, Florida on August 12, 2018 at 4:07 p.m. Eastern Time. This mission was developed by Johns Hopkins University's Applied Physics Laboratory and the Solar Terrestrial Energy Science Stereo mission. It was named after Eugene Parker, an astrophysicist who predicted the existence of solar wind as early as 1958. It takes around 16 months for the probe to complete one orbit around the Sun. The reason why it takes so long is because the probe literally flies through our Sun's atmosphere, which is called the corona. The corona is the outermost layer of our Sun's atmosphere, and it extends thousands of miles into space. It has a temperature of over 1 million degrees Fahrenheit, which is about 15 degrees Celsius. For reference, the temperature on the surface of our Sun is about 10,000 degrees Fahrenheit or 5,500 degrees Celsius. So the corona is extremely hot. The reason why the Parker Solar Probe can survive temperatures that high is because it doesn't get as hot as those temperatures suggest. Here's why. Our Sun radiates energy in all directions. That means even though the Parker Solar Probe will be very close to our Sun, the majority of the photons won't hit the spacecraft since they're going in all different directions. Instead, the photons will pass right by the spacecraft and go into deep space. This is why the Parker Solar Probe will have its solar panels facing backwards while it's flying towards the Sun. This way, the photons will hit the spacecraft's huge heat shield instead of the solar panels, which would destroy them. The heat shield is specifically designed to withstand up to 15 degrees Celsius. Once the photons hit the heat shield, they'll get bounced back into space and eventually reach our Earth. The entire point of sending the Parker Solar Probe that close to our Sun is to allow it to study things that are impossible to study from Earth. And here's why that is. If you want to send a spacecraft to another planet in our solar system, let's say Jupiter, then you need to make sure that your spacecraft is protected from cosmic radiation. Cosmic radiation is made up of protons, nuclei, and electrons traveling at incredibly high speeds. These particles are constantly bombarding our solar system, and they can cause serious damage to sensitive electronics. This is why spacecraft like Voyager 1 and 2 had to be fitted with radiation shielding. However, if you want to study our Sun, then you actually want your spacecraft to experience as much radiation as possible. Radiation is really good at stripping away gases from a planet's atmosphere. Scientists think that billions of years ago, our Venus and Mars had thick atmospheres just like Earth, but today their atmospheres are super thin. And scientists think that radiation played a big part in that. This is why the Parker Solar Probe is not only flying extremely close to our Sun, but it's also flying directly through our Sun's atmosphere. This allows the probe to collect data that we can use to better understand how radiation strips away the gases from planets' atmospheres. Another thing that makes the Parker Solar Probe so incredible is that it studies our Sun's solar wind. The solar wind is a stream of charged particles that flow outwards from our Sun. It's always flowing, even when our Earth casts its shadow on the Sun during a solar eclipse. And it's thanks to our Sun's corona that the solar wind exists. When the photons exit the corona, they collide with the gas particles in our Sun's atmosphere and knock them loose. These particles are mostly protons, and they travel outwards at incredible speeds. And that stream of particles is what we call the solar wind. Now, it's not all protons. Sometimes the solar wind carries with it electrons and even heavier nuclei. And the solar wind isn't always peaceful. Sometimes it can carry with it coronal mass ejections, which are giant bursts of plasma. These ejections can last anywhere from a few days to several months. And when they hit our Earth, they cause what we call geomagnetic storms. Geomagnetic storms can disrupt our satellites, our telecommunications, and our power grid system. And they can cause major problems for astronauts in space. They can also cause auroras, which are beautiful displays of light in our night sky. This is why the Parker Solar Probe is designed to study our sun's solar wind. By studying the solar wind, we can get a better idea of what kind of particle activity we can expect from our sun. And the closer we can study these activities, the better we can predict when a geomagnetic storm will hit our Earth. The Parker Solar Probe reaches speeds of over 430,000 miles per hour. And it does that by using gravity assists. Gravity assists are a way to speed up a spacecraft by using the gravity of a planet. To perform a gravity assist, a spacecraft simply flies by a planet at just the right angle. As the spacecraft approaches the planet's gravity will pull it towards itself. At the same time, the spacecraft will be moving forward, and the combination of these two forces will speed up the spacecraft. In total, the Parker Solar Probe performed 7 gravity assists on its way to our sun. 4 of those were from our planet, Earth, and 3 were from our largest gas giant, Jupiter. And finally, the last reason why the Parker Solar Probe is so incredible is because it is the first spacecraft to fly through our sun's atmosphere. No other spacecraft has ever done this before. The Parker Solar Probe began collecting scientific data on November 5, 2018, and since then, it's been making amazing discoveries. For example, the Parker Solar Probe discovered that our sun has giant bursts of activity that last 50 days. These bursts of activity seem to come from sunspots that are located near each other, and scientists think that they might be connected. If they are connected, then that means that our sun's activity might be linked together in some way. And that could help us better predict solar storms. The Parker Solar Probe also found that our sun's atmosphere is much more turbulent than we thought. Our sun's atmosphere is constantly moving around, and that movement can cause a lot of turbulence. And that turbulence can cause our sun to vibrate. Scientists think that these vibrations might play a role in how our sun's atmosphere interacts with our Earth's magnetic field. And if they can figure out how these vibrations work, then they might be able to help protect our satellites and our power grid system from geomagnetic storms. The Parker Solar Probe has been making amazing discoveries about our sun, and it's only been in space for 5 years. Who knows what else it might find in the next few years? Thanks for watching. If you enjoyed the video, please subscribe and check out my other videos. Thanks for watching, like and comment your thoughts. Subscribe for more videos. Till then, bye.